Now we're going to look at improper integrals that have infinite discontinuities either at a boundary or somewhere within the integral. So it's going to be a very similar process to what we did with the infinite bounds. It's just instead of c approaching positive or negative infinity, it's going to be approaching that discontinuity on whichever side that it appears. And again, we're going to have the idea that it converges if the limit exists or it diverges if the limit does not exist. So something like this, the integral from 0 to 2 of 1 over x, or the cube root of x with respect to x. I know that this does not exist as at x equals 0, and I have 0 as a bound. So I'm going to observe that because we're going from 0 to 2, we want to look at the limit as c approaches 0 from the right. These are all numbers that are slightly greater than 2. If it had been on the other side, we would do the limit from the left. That's going to be the integral from c to 2, and let's go ahead and write that as x to the negative 1/3 power. So we can integrate. So I get x to the negative 1/3 plus 1 over negative 1/3 plus 1, and that all goes from c to 2. We're taking the limit as c approaches 0 from the right of this now becomes, this is a 2/3 on the bottom, so 3/2 x to the 2/3 power from c to 2. And then I'm going to have 3/2 times 2 to the 2/3 minus c to the 2/3. And that's all going to be the limit as c approaches 0 from the right. So positive c's, we don't have to worry about anything with radicals, although this would be an odd root anyway. But this will be 3/2 times 2 to the 2/3 minus 0, or just 3/2 times 2 to the 2/3, and 2 to the 2/3 is the cube root of 4. If you wrote 2 to the 2/3, that would be okay also. But we say that this one converges because the limit exists and has a value. Next one is very similar. We have 1 over x to the 5th. Our bounds are 0 and 5, and we know that this doesn't exist at x equals 0. So I'll make it the limit as c approaches 0 from the right, because again, we're greater than 0, of the integral from c to 5 of x to the negative 5 dx. So I'm just going to evaluate this integral, which will be x to the negative 4 over negative 4 from c to 5. Or you could write that as negative 1 over 4x to the 4th from c to 5. So we're approaching 0 from the right. And we're going to have negative 1 over 4 times 5 to the 4th minus a negative 1 over 4 times c to the 4th. And as we're approaching 0 from the right, this is a constant. This is going to be something that's going to approach infinity. So a negative constant plus infinity is going to be a positive infinity. So we say that this one diverges. The limit does not exist. This next one, you can see that the problem is in the middle. We're going from negative 2 to 2 of 1 over x squared, and we have a problem at 0. Now, you may remember from your previous classes that this is an even function, and we're going from negative a to a. So you could make it 2 times the integral from 0 to 2 of 1 over x squared dx and go from there. Or if you want to split it up, you could make it the integral from negative 2 to 0 of, let's just make that x to the negative 2 dx, plus the integral from 0 to 2 of x to the negative 2 dx. And then here we would have the limit as c approaches 0 from the left, because these numbers are less than 0, of negative 2 to c of x to the negative 2 dx, plus the limit as c approaches 0 from the right, because these numbers are greater than 0, of the integral from c to 2 of x to the negative 2 dx. Either way is fine. Both of these are going to give me negative 1 over x. So we'll have negative 1 over x from negative 2 to c, plus the limit as c approaches 0 from the right of negative 1 over x from c to 2. So this is going to give me the limit as c approaches 0 from the left, numbers less than 0, of negative 1 over c minus a negative 1 over negative 2. And here we'll have the limit as c approaches 0 from the right of negative 1 over 2 minus a negative 1 over c. Okay, so here we've got something, these are numbers that are slightly less than 0, so these are slightly negative numbers. A negative number over a slightly negative number is going to give me positive infinity. Here we've got 1 over positive infinity, so infinity minus 1/2, that's still infinity. So this is going to diverge. This is what we call a doubly improper integral because the 1, if you plug in a 1 here, you would have 1 times 0, so this is 1 over 0. That one's not defined. And then this is an infinity, so that's obviously improper. So we're going to split this at some convenient point. Let's choose x equals 2. So the reason why I'm going to use 2 is because I can plug a 2 into this and everything's defined. So I have the integral from 1 to 2 of 1 over x natural log of x dx plus the integral from 2 to infinity of 1 over x natural log of x dx. So here the problem is the 1. Here the problem is the infinity. So I'll take the limit as c approaches 1 from the right of the integral from c to 2 of 1 over x natural log of x dx. Plus, here we'll do the limit as b approaches infinity of the integral from 2 to b of 1 over x natural log of x dx. So first we have to evaluate these integrals, and I did that over here. You can pause the video and check this out if you need to. This is u prime over u, where u equals natural log of x and u prime equals 1 over x. So it looks a little strange, but it evaluates to the natural log of the natural log of x. So here we'll have the limit as c approaches 1 from the right of that, the natural log of the absolute value of the natural log of x, and that goes from c to 2. And here we'll have the limit as b approaches infinity of the natural log of the natural log of x inside absolute values from 2 to b. So we got to figure out what to do with this limit, and but let's go ahead and plug everything in first. So I'm going to have the limit as c approaches 1 from the right of the natural log of the natural log of 2, absolute value, minus the natural log of the absolute value of the natural log of c. And here I'll have the limit as b approaches infinity of the natural log of the absolute value of the natural log of b minus the natural log of the absolute value of the natural log of 2. Okay, so here we go. We need to talk about what happens as c approaches 1 from the right of the natural log of c. So remember, your natural log graph looks like this. So as c approaches 1, the natural log is approaching 0. So this part in here is approaching 0. And for the outer natural log, as the inside approaches 0, as the whatever's inside the natural log approaches 0, the whole thing approaches negative infinity. So this particular limit, this is a constant. It's not a pretty constant, but it's still just a constant. The natural log of the absolute value of the natural log of 2. This is approaching minus negative infinity. On this one, we've got b approaching infinity. So as b approaches infinity, natural log of b approaches infinity. So this is infinity, which means that the natural log of something approaching infinity is also going to approach infinity. And then this is just a constant. So the constants almost don't even matter. I mean, they do cancel out, but what we end up with is positive infinity plus positive infinity. And when you put two infinities together, you just get more infinity. So this one diverges as well. There are some special types of improper integrals that you will see appear from time to time, and they take the form, the integral from 1 to infinity of dx over x to the p, or you might see it written as 1 over x to the p dx. And this is where we basically have x to some power. And these are special because everything that goes on here depends on the power p. So the integral is equal to 1 over p minus 1 if p happens to be greater than 1. But if p is less than or equal to 1, we say this thing diverges. So if it was the integral of dx over x, p would be equal to 1 and it would diverge. So this example, the integral from 1 to infinity of dx over x to the 5th, p here is 5. So since 5 is greater than 1, this one is going to diverge to 1 over 5 minus 1, which is just 1 over 4. And I think I said diverge. It is going to converge. Converges to 1/4. This one we have the integral of the square root of 1 over x. So you might want to do a little bit of work on this one first. So this is going to be the square root of 1 over the square root of x, which is 1 over x to the 1/2 dx. So here p equals 1/2, which is less than 1, and we can see from our chart that this one just diverges. And we don't have to do any extra work there. So there you have it, two special types, and if you see those, you're welcome to use those rules.